So we're going to take a look this time at certain powers, and specifically we're going to look at ones that are base 10. And so what that means is we're going to look at what is 10, so 10 to the power of something. And you'll notice we have a bunch here that we're going to take a look at, and what do they represent. So first of all, okay, a power, okay, is an expression which uses a base and an exponent to display a value. Okay, so they do it's a base and an exponent to display a value. Okay, and that base is any number. Okay, we saw in the previous lesson we can use any number in that, but in this case here, that number that we're going to use is 10. So let's complete the chart to show the different powers of 10. So we're going to go through the powers of 10 and what they represent. So the first one here, 10 to the power of 1, is just 10 by itself. So it's just 10. And that number in words, well, that's pretty simple. It is 10. Okay, we've used this one a lot, and most of the numbers that we see here are going to be pretty straightforward. 10 to the power of 2 is 10 times 10, and this is 100. Okay, our number in words is 100. And now you may start to see a pattern forming with these values, and if you do, that's awesome, because there is a pattern, and it's definitely a legit pattern. The next one, 10 to the power of 3, okay, is 10 times 10 times 10. So 10 times 10 is 100, times 10 is 1,000, and we'll write that out as well. 1,000 is 10 to the power of 3. Now, some of you are like, I got the pattern, and others of you are like, I don't see it yet. Well, hopefully we start to see this pattern pretty quickly. I'm really hoping so. Yeah, you'll notice that with each one of these, we're going up by 1 0, right? So 10 to the power of 1 has 1 0. 10 to the power of 2, 2 zeros. 10 to the power of 3, 3 zeros. 10 to the power of 4, any guesses? I hope you all yelled 4 zeros, because that is for sure the way that it is. And this is the same as 10,000. Okay, so as we add an extra number onto here, as the number gets bigger as the exponent, we're always adding another 0 to our to 10. Okay, so to speak, here, or to the 1, I guess. We have 1 with 1 0, 1 with 2 zeros, 1 with 3 zeros, 1 with 4 zeros. And our next one is a 1 with 5 zeros, and this would be 100,000. Okay, and we're going to keep on going here. 6 zeros is 1 million. Okay. Let's see here. Just going to make sure I get the right pen here. 7 zeros would be 10 million. Now, something you'll notice here is when I write it out, I use a comma to separate all of my. I use a comma to separate my values. Threes. Okay, so I'll do that each time here. If we have 8 zeros, we have 100 million. And finally, we have 9 zeros, and this is 1 billion. Okay, now we could keep on going forever and ever and just keep adding zeros. Our numbers would get a whole lot bigger. We'd have to add different suffixes at the end. Okay, we have 100,000, and then 10,000, 100,000, million, 10 million, 100 million, billion, 10 billion, 100 billion, and so on and so forth. We're just going to keep adding on those suffixes there. Now you'll notice, and again we talked about this, as the value of the exponent increases, the number of zeros in the value increases as well. Okay, and this is what we would call a 1-to-1 ratio. 1 in the power, 1 0. 7 in the power, 7 zeros. It's a 1-to-1 ratio, as the number of zeros in the standard form is equal to the number in the exponent. Okay, so they are exactly equal. And that's important that we see that, because it is a pattern that we are going to follow, and we're going to be using that as we keep going. Now, as the exponents go up, the number of zeros goes up, as we mentioned. What happens when the numbers go below 0? And so we're going to take a look at what happens when they go below 0. Well, 10 to the power of 1, as we mentioned, is 10, and this is just a little repeat of what we had earlier there. And now if we go the other way, 10 to the power of 0 means we have a 1 with no zeros, and this is just 1. And we're going to talk about why the power of 0 gives us 1 in this case, and we'll actually look at why it's that way all the time. We'll look at that a little bit later on, but for right now we're just going to accept it for exactly the way it is. 10 to the power of -1, well, you'll notice here we can't really take away any more zeros, but what we're going to do actually is we're going to move the 1 more space over, and this is going to be 1/10. Okay, it's a decimal. Now we're moving into the decimals, and this is going to actually continue as we go farther and farther. Okay, 10 to the -2 is 0.01 or 1/100th. And finally, 10 to the power of -3 is 0.001, and this is 1/1000th. I think there's a T in there as well. Yeah, or a D. There we go. Okay, so you'll notice here that as the number gets smaller, okay, we're getting to the negatives, our 1 is actually moving more and more into a decimal place. It's not becoming negative. That's not the case, just the exponent's negative, but the number is in fact definitely changing the way that it looks, and that's important that we recognize. Now this pattern will continue through all the powers of 10. The negative exponent represents the number of decimal places the number now has. So you'll notice here a -1, 1 decimal place, -2, 2 decimal places, -3, 3 decimal places based on that number, and that's based on that 1. This system of describing powers of 10 is called a base 10 system. Okay, so that's why we look at base 10. We also use it for something called scientific notation, which we're going to look at a little bit later. And this is a way to describe really big or small numbers simply, or quickly, I should say. Okay, it's a way to describe these numbers really quickly. Instead of writing out a whole bunch of decimal places or a whole bunch of zeros, we can describe it much quicker based on scientific notation, which is based on base 10. So in the continuation of this lesson, we're going to look at base 10, and then after that, we're going to take a look at scientific notation.